Welcome to another anynode video workshop. In this edition, we invite you to sit back and watch how to set up the load balancer in the Azure portal. In our example, we use the Azure Load Balancer in any node with a Teams node with multiple instances in a master client environment on Azure VMs. Of course, the Azure Load Balancer can also be used with other application scenarios. In practice, this feature can be used for high availability or load balancing. For our example, we have prepared a ready-made master client configuration with failover on 2 Azure virtual machines. If the primary anynode goes into maintenance mode or the VM fails, the secondary anynode, called replica in the diagram, should take over all tasks. However, a look at the dashboard of the secondary system on the Teams node now shows that the Teams node sends option packets to the Teams direct routing servers, but does not receive any. This is a normal reaction to this configuration, as the Teams server is not aware of the secondary anynode. When setting up Teams, it is possible to use multiple FQDNs. If you want to use the integrated replication service from any node, the nodes on the machines are currently configured identically. This means that it is not possible to enter different FQDNs in the nodes. To create a failover system, both anynode systems can be reached with the same address using a load balancer IP address. The Azure Load Balancer periodically performs a health probe, sending packets to a specific port on the VM to verify that it is still open and that packets are being responded to. You need an Azure account with a valid subscription and a ready anynode master client configuration on Azure virtual machines. If required, use our corresponding video workshops Azure Deployment and Master Client Replication. Log into the Azure portal and search for Load Balancer in the top search box. Load balancers will now appear in the services. Click on it. Then use the Create button to add a new load balancer. The Azure subscription is entered automatically. Select a valid resource group, which in our example is Anynode Lab. The resource group is the logical container assigned to the subscription. The load balancing module is then created within this resource group. If you have not yet created any resource groups, you can still do this now with Create New. Assign a freely selectable name for the load balancer. If possible, the load balancer should always run in the region where the virtual machines are located. In our case, this is Europe, Northern Europe. At Type, select whether load balancing should be internal or public. Internal load balancers are used to perform load balancing for data traffic within a virtual network. Use internal if you can access all anynode instances that send you load over the virtual network. Any node does not require a public IP even with a public load balancing module. A public load balancer can establish connections from VMs on a virtual network to internet traffic. For our example, we choose public. For more information on the topic, see the Microsoft documentation. The Azure Load Balancer is available in 2 different stock keeping units, SKUs Basic and Standard. The Standard SKU is preset and is also recommended by Microsoft, but it is a premium variant and should only be selected for the corresponding price range of the VM. A standard load balancer can therefore not be assigned a basic VM. A standard SKU load balancer offers more features and functionality, such as a larger backend pool and availability zones, but also requires more configuration effort. For a list of Load Balancer Standard and Load Balancer Basic features, see the Microsoft documentation. In this video workshop we use the basic variant and will later show the further settings for the standard variant. The Azure Load Balancer Standard supports cross-region load balancing, enabling geo-redundant high-availability scenarios. You can select Instant Global Failover with the global setting only in the standard variant. This is not available in the basic variant. In our scenario, the load balancer is assigned to a public IP. The load balancer can be reached under this public IP address. At this point, an existing IP address can be selected. We create a new IP address with Create New. Then enter the freely selectable name for it. For our example, we select Load Balancer Tutorial English IP. In most cases, a static IP address is appropriate because it does not change regularly like a dynamic IP address. Azure assigns the IP address from a pool of available IP addresses at the Azure site where the resource is created. Select whether an IPv6 address should be used in addition to the IPv4 address. In our example, we do not need an IPv6 address. The tags are optional and can be used in a freely definable way to enable the categorization of resources and the display of a consolidated statement. For example, it would be possible to enter application as the name and anynode as the value. One can then later filter by these values to find the right load balancer. If you want to create a lot of load balancers that are all built identically, it is possible to download a template for automation. You can now start the creation of the load balancer module with the Review and Create button. Before the creation is created, there is again a summary of all settings. If all settings are okay in the summary, click on Create. After a few seconds, you can switch to the newly created load balancer with Go to Resource. In the standard variant, there are some additional settings to be considered. The Azure Load Balancer standard supports cross-region load balancing, enabling geo-redundant high-availability scenarios. You can select instant global failover with the global setting only in the standard variant. This is not available in the basic variant. Azure Load Balancer supports scenarios with availability zones. You can use the load balancer standard to increase availability across the scenario by aligning resources to zones and deploying across zones. A load balancer can be zone redundant, zonal, or non-zonal. For more information, see the Microsoft documentation. Select a zone redundant. For our example, we will use one zone. Routing preference is where you specify how your traffic is routed between Azure and the Internet. Selecting Microsoft Global Network routes traffic over the closest Microsoft Global Network. The Internet route option uses an ISP transit network. The price for outbound data transmission varies depending on the routing selection. The routing option of a public IP address cannot be changed after it is created. The Backend Pool is a critical component of load balancing. The Backend Pool defines the group of resources that process traffic for a given load balancing rule. The configuration of the Backend Pool is the same for the standard and basic load balancer. However, you cannot select basic VMs for a standard load balancer. Click Add to assign a Backend Pool consisting of the two VMs hosting the anynode instances. Of course, this can be more than two instances. First, assign a freely selectable name for the Backend Pool. In the virtual network settings, select the supporting virtual network resources. If you have not yet created a virtual network in Azure, see the Microsoft documentation for how to proceed. In our case, the virtual network is anynode training EUVNet 391. We now link this to the two VMs running the anynode instances with the master client configuration. To do this, virtual machines must be selected. Only then the virtual machines can be added in the field below. Depending on the network infrastructure, determine the IP version. Click on Add. In the right pane, a list now opens with the available VMs including details, which are set up on Azure. For our example, we will select the two VMs running the anynode instances with the master client configuration, LBVM1 and LBVM2. Please note that VMs can only be in a backend pool if they have been created in the same availability set. Then click on the Add button at the bottom right. The VMs are now in the overview of the virtual machines and must be finally added with the lower left Add. The load balancing rule takes over the definition of the actual monitoring and forwarding of the incoming traffic. In our example on port 5067 TCP of the public IP address, this port is taken by default by anynode for communication with Teams. The packets are forwarded to port 5067 TCP of the two anynode instances, depending on the result of the health probe. In the normal operating state, the load balancer distributes the incoming traffic to both instances, provided that both anynode instances are operational and respond to the health probe on port 5067 TCP. If the health probe fails on either instance, the load balancer forwards the incoming traffic to the remaining active instance if an active passive system is set up with the anynode instances. Please note that in anynode, the close network ports and do not accept new traffic option is selected for the operational condition in the SIP transport object. Anynode then closes the port on an inactive system. Click on Load Balancing Rule in the left menu tree and on Add. At this point, we will first show you only the settings for the basic variant. For the standard variant, there are some important additional settings to consider, which we will present to you in the following. The name of the load balancer rule is, as always, freely selectable. The IP version again depends on your network environment. The front-end IP address was generated earlier with the creation of the load balancer and can be selected here. We leave the protocol at the default value TCP. Enter the port of the two anynode instances to which the packets are sent to the Teams node, as mentioned earlier. This is port 5067. At the backend port, you can select whether the data traffic should be forwarded to the virtual computers in the backend pool via a port other than the one used by the clients for communication with the load balancer. This is not the case in our example, and therefore we enter port 5067 here as well. We have created the backend pool earlier and given it a name. We can now select this name here. Create a new health probe if you have not created one before. As always, you can choose the name freely. The protocol is TCP and the port is again 5067. For interval and unhealthy threshold, you can use the default values. These values specify how often the health probe is performed and from how many consecutive errors the error threshold is reached. The unhealthy threshold is the number of consecutive test errors above which a virtual computer is considered inactive. Click OK. Session persistence specifies whether traffic from a client should be processed by the same virtual machine in the backend pool for the duration of a session. The None option specifies that successive requests from the same client can be processed by any virtual machine. The Client IP option specifies that successive requests from the same client IP address are processed by the same virtual machine. The Client IP and Protocol option specifies that successive requests with the same combination of client IP address and protocol will be processed by the same virtual machine. In our scenario, Client IP is the correct setting. The default behavior of the Azure Load Balancer is to discard flows without feedback when the idle timeout of a flow is reached. In Azure Load Balancer, a flow is an active session between the load balancer and the virtual machine. By default, the value is set to 4 minutes. If the duration of an inactivity period exceeds the timeout value, there is no guarantee that the session between any node and Teams will be maintained. We adopt the default value of 4 minutes at this point. In our scenario, floating IP must be disabled. For more information, see Microsoft's documentation. We accept the default value disabled here. Click Add to finally add the load balancing rule. You will now see an overview of the finished load balancer configuration. The settings with the standard variant selected include some other important settings, which we will now present to you. First, make the settings known from the chapter Create Load Balancing Rules, Basic, and note the additional settings in the lower area for this variant. Be sure to enable the recommended setting at Outbound Source Network Address Translation for outbound traffic. The upper rule use outbound rules to provide backend pool members access to the internet ensures that any node can communicate to the outside world. Do not use the lower rule. In the standard variant, you must also define the outbound rules so that any node can also connect to the outside world. Here you can explicitly define the SNAT, Source Network Address Translation, for a public load balancer default instance. Outbound rules give you complete control over outbound internet connectivity. Setting up an outbound rule is required so that voice packets sent and received via UDP can be exchanged between any node and the remote peers. If this rule is not set up, a call can be established but the participants cannot hear each other. The outbound rule ensures that the available ports are distributed among the available machines. For more details, see the Microsoft documentation. Click on Outbound Rules and add in the left menu tree. As usual, set a freely selectable name for the outbound rule. Select the already created IP address from the load balancer. In our example, we use UDP as protocol. We have already created the backend pool earlier. Select this backend pool. The port allocation defines how many ports the load balancer can open per VM. Under port allocation, manually specify the number of outgoing ports that can be used for outgoing data traffic. At Choose By, you can choose either ports per instance or maximum number of backend instances. In our example, we will select maximum number of backend instances and set it with the number 2. Click Add. Now verify that the Teams node on the secondary anynode system is receiving options packets. Put the primary anynode in maintenance mode so that the secondary system now becomes the active system. In monitor mode, switch to the secondary system, named Replica in our case. Click on the Teams node and watch the options packets display. Refresh the display several times in a row with refresh. This brings us to the end of this tutorial video, and thanks for your attention.